Dear students, good morning. The last class we had discussed on the topics distance and displacement and its some characteristics. Today class, let it be see what kind of the physical quantities are there, the distance and displacement. If you travel to Delhi from your relative's place and if someone asks you what the distance you travel, what do you reply? You say it was like 250-kilometer run from Chandigarh. You do not tell him that 250 kilometer towards east, then west. We just say 250 kilometer. That means we describe it only in magnitude, but we do not specify direction. So it is a scalar quantities. How can we define scalar quantities? The quantities that depend upon magnitude and not direction are called scalar quantities, or those physical quantities which are having magnitude but not direction. Now, if you travel a straight short path in a specified direction, then you can say you travel 95 kilometers towards east. So in this case is specified the direction. So the displacement falls in the category of vector quantity. Why this physical quantity is vector quantity? As it is having specified direction, so the displacement is vector quantity. Those physical quantities that depend upon magnitude as well as directions, or those physical quantities which are having both magnitude and directions, are called a vector quantity. This is the definition of vector. Now we are going to a very important session where we discuss on the topics: first, uniform motion; second, non-uniform motion. In our day-to-day life situation, we come across motions where objects may cover equal distances in equal interval of time, or objects may cover unequal distances in equal interval of time. First of all, just we think about uniform motion. Consider an object moving along a straight line. Let it covers 25 kilometers in the first hour, 25 kilometers more in the second hour, 25 kilometers in the third hour, and 25 kilometers in the fourth hour. Once again I repeat, the same object travel 25 kilometers in the first hour, in second hour also the same distance 25 kilometer, third hour the 25 kilometer, and also in the fourth hour the distance cover 25 kilometers. In this case, object traveled with the equal distances in equal interval of time. So we can say it is said to be in uniform motion. Let us consider another example. A train is supposed to travel to Delhi and it covers the same distance in the same interval of time. The figure shows the table which gives the distance and times are given in the separate rows. Distance traveled by the train in first hour is given 90 kilometers. Next second hour added the 90 kilometer, it is come to be 180, means second hour 90 kilometer. In third hour for the 90 kilometer total it to be 270, and fourth hour again 90 kilometer, and total distance is to be 450 kilometer. So here we see that train travels equal distance of 90 kilometer in each hour. So it is said to be moving with the uniform motion. How can we define uniform motion? When a body covers equal distances in equal interval of time, the body is said to be in uniform motion. Did you clear the concept of uniform motion? Yes. Another example. Motion of planets around Sun. They revolve at a constant speed. So the distance traveled in every equal time period is equal always. One more example is given. A train running at a speed of 90 km per hour, if it is uniform motion, yes, we can assume it is the uniform motion. Next, we look into the second one. What is that? It is non-uniform motion. We all the members are now in lockdown period. We know India is facing the COVID-19 challenge by determinations and concern. So we are safe always to stay at our own home. You know, nowadays the vehicles are almost somewhat completely restricted to run in public road with some condition given by government officials based on the zone divider, which you read from the daily newspapers. So, no traffic crowd is there. Suppose normally when a bike is moving on a crowded traffic, the distance covered by the bike will be different in equal interval of time. So we say that bike is in non-uniform motion. Let us see another example. A bus traveling to Delhi covers 40 km in 1 hour, and then due to huge traffic on road travels 25 km in the next hour, and then in another hour takes a break for having lunch. Then speed up the bus and travels 50 kilometers in another hour. It can be shown as in the figure. The table as the distance, time, distance 40 kilometer in 1 hour, second hour it is how much kilometer? 25 kilometers, and third hour it is 50 kilometers. In this case, you see that unequal distance is traveled equal interval of time. So first the bus 40 kilometer, second hour due to the huge traffic it is only 25 kilometers. Next times section it is not continue the journey because they were ready to have the lunch. After the second time period could be count to be third hour, travels 50 kilometers, total distance to be 115 kilometer, travel distance in 3 hours 115 kilometers. Here unequal distance traveled by the bus in equal interval of time. Can you say it is in uniform motion? No, because unequal distance cover in equal interval of time, so the bus is said to be in non-uniform motion. How can we define non-uniform motion? When a body covers unequal distance in equal interval of time, the body is said to be in non-uniform motion. One more example, an athletes running. They are slowly initially in the race, but as the race progresses, their speed increases. See the figure. Let us say they cover 1 kilometer in the first hour, and after 1 hour they cover 3 kilometers. So the distance covered in 1 hour is changing. Okay, another example, when brakes are applied to speeding car, how the distance unequally covered, it may be stop at last. The distance covered differently in equal interval of time, so it is said to be in non-uniform motion. The next physical quantity we have to study is speed. What is speed? Different objects may take different amount of time to cover a given distance. Some of them move fast, some move slowly. We know jet airlines will be flying very fastly. To cover the same distance, the ship needs more time. Also, different objects can move at the same rate. One of the easy way of Expressing this rate of motion of an object is to find out the distance traveled by the object in unit time. This quantity is referred to as speed. What is the speed? Speed is just the rate of moving a body. This is the distance traveled by an object in unit time. It is a scalar quantity. Its SI unit is meter per second. So mathematically, speed is equal to distance divided by time. See the picture. What can you understand from the picture? Here there is only one car. It travels 20 kilometers in 1 hour. So speed is equal to 20 kilometer divided by 1 hour is equal to 20 kilometer per hour. The practical unit of speed is kilometer per hour. How can we convert 1 kilometer per hour into corresponding SI unit? What is SI unit? Meter per second. 1 kilometer per hour is equal to 1000 meter per 3600 second. 1 kilometer, 1000 meter, 1 hour, 3600 second. So it will be equal to 10 by 36 equal to 5 by 18 meter per second. Or conversely, we can convert 1 meter per second into corresponding value of kilometer per hour. That is equal to 18 by 5 kilometer per hour. The next topic is average speed, which is one of important topics in the chapter and the problem also. The problems are to be given in second last page. In order to understand it, let's take an example. If we travel to Delhi in 4 hours and if your friend asks you, what is your speed? You may say 60 km per hour or 40 km per hour. This is just only average speed. As you do not reply that in first hour it was 50, then in another hour it was 45 km per hour. Actually, we have calculated it by dividing measure of total distance of your destination from where you started by total time that you took to reach. So we say that this measured quantity is always variable in equal interval of time throughout your journey. So we say this motion is non-uniform motion and the physical quantity measured is the speed, which is average speed. The speed calculated is the average speed because the motion whose speed is always variable. For non-uniform motion, the average speed of an object is obtained by dividing the total distance traveled by an object by total time taken. That is, V is equal to S by T. V stands for average speed, S stands for total distance traveled, and T stands for total time taken. The next physical quantity is velocity. We know that the speed gives us the information about the distance with respect to time, but does not specify the direction. So we are in immediate need of physical quantity that gives the information as speed and also specify the direction. So here comes velocity. It is the distance covered by a body per unit time in a given direction, or it is the rate of change of displacement. Here direction of motion is always specified. In another way we say the velocity is the speed in specified direction only. Velocity is equal to displacement by time. Here the speed of an object moving in definite direction is also called velocity. It is the vector quantity. It is a complete quantity. Its SI unit is meter per second. The next physical quantity is average velocity. The velocity of an object can be uniform or variable. It can be changed by changing the object speed, direction of motion, or both. When an object is moving along a straight line at a variable speed, the magnitude of its rate of motion is expressed in terms of average velocity. That means the average velocity is the velocity which is to be calculated for those bodies which are in non-uniform motion. Like as we done in calculating the average speed where the motion is non-uniform motion, average velocity is mathematically expressed as total displacement divided by total time, same way used to calculate average speed. Suppose the velocity of the object is changing at uniform rate, then average velocity is the arithmetic mean of initial and final velocity for given period of time. That is, average velocity is equal to initial velocity plus final velocity divided by 2. V average is equal to U plus V divided by 2, where U stands for initial velocity, V stands for final velocity. Next, we are going to differentiate between initial and final velocity. Suppose a scooter is at a rest, and then when it starts and now it is moving at a speed of 20 meters per second. Then the velocity which it possessed earlier is initial velocity, and what it possesses now is its final velocity. That is at a rest, so 0, its initial velocity 0, and now moving at 20 meter per second, so its final velocity is 20 meter per second. Similarly, if I say that scooter is moving at 20 meter per second and then its speed increases to 40 meter per second, then what is its initial velocity? What is its final velocity? Can you say the initial velocity is 20 meter per second and final velocity is 40 meter per second. In the same say scooter is moving with a speed of 40 meter per second and then suddenly brakes are applied and it stops. Then in this case, what will be the initial velocity and what will be the final velocity? The initial velocity is 40 meter per second and final velocity will be 0. Why? Because it stops. Initial velocity is denoted by U and final velocity is denoted by V. Let us discuss on problems. Consider yourself going to a shop on a cycle. You stop cycle many times on the way and then you come from the shop to your home. And these data are given. Distance from shop to home is equal to 3 kilometers. Time taken from home to shop is 1 hour and time taken from shop to home is equal to 2 hours. What would be the average speed and average velocity? Average speed is equal to total distance divided by total time. Here total distance. What would be the total distance? Total distance, it is 2 journey 3 kilometer and fro journey is also 3 kilometer. Since the distance between the shop and home is 3 kilometer, total it will be equal to 6 kilometer. And total hours 1 plus 2 hours. For 2 journey it will be 1 hour and for journey it will be 2 hours. Total time is equal to 6 hours. Then average speed is equal to 6 by 3, that is equal to 2 hours. Next, what should be the average velocity? Average velocity is equal to total displacement divided by total time. That is equal to 3 km minus 3 km divided by 1 plus 2 hours. Since initial point and final point or starting point and finishing point are coincided, then displacement will be equal to 0. Then what should be the average velocity? It is equal to 0 displacement divided by 3 hours is equal to 0 kilometer per hour. Next, see another problem. The odometer of a car reads 2000 km at the start of a trip and 2400 km at the end of the trip. If the trip took 8 hours, calculate the average speed of the car in km per hour and meter per second. What is odometer? Odometer is the device used to measure the distance traveled. And the speedometer is the device used to measure the speed of vehicle at any instant of time, or instantaneous value of speed, or the speed at the moment will be calculated by speedometer. Odometer, the distance or total distance covered by vehicle is calculated by the device. Here we know average speed is equal to total distance divided by total time. Given initial odometer reading is equal to 2000 km, final odometer reading is equal to 2400 km. Then total distance travel is equal to final reading minus initial reading is equal to 2400 km minus 2000 km is equal to 400 km. Total time is 8 hours. Then average speed is equal to 400 km divided by 8 hours, that will be equal to 50 km per hour. By the questions, we also have to calculate this value in meter per second. How to convert in meter per second? Given us average speed 50 km per hour, you just multiply this value by 5 by 18. Since 1 km per hour is equal to 5 by 18 meter per second. Then multiply it by 5 by 18, that will be equal to 13.8 meter per second.